How a hydroelectric power plant works, what are its major components and their functional importance, what is the role of surge tank in plant operation, what are the merits and demerits of hydel systems.
Bismillahirrahmanirrahim. Assalamu alaikum. My name is Zishan. I welcome you all in the series of Power Plant Insight. I feel necessary to start the session from very basic knowledge of understanding about how a power plant works. The very next question that comes to your mind that about which power plant you are talking about. Are you talking about of a conventional power cycle or a non-conventional system? Actually, each type of power plant has its own operational philosophy. So coming towards the agenda of today's video, we will be talking and discussing about the hydroelectric power generation. We will discuss the working cycle, the operational understanding of the hydel systems. We will discuss in detail of all the equipments and all the components that actually constitutes a hydel power plant. And at last, we will discuss about different merits and demerits of hydel systems. A hydropower is basically an economic, renewable and non-polluting source of energy. It generates electricity by utilizing the energy of a falling or a flowing water. Let me explain this concept in more simple words. When the water is stored at a considerable height, it has a potential energy in it. When this water is allowed to flow into a channel, in technical terms it is called as penstock. This potential energy of the stored water is converted into the kinetic energy. That kinetic energy is further converted into the mechanical energy at water turbine. That water turbine is coupled with a generator that generates the electricity. So the mechanical energy is converted into the electrical energy. This is the basic concept of hydroelectric power plant. Now let us discuss in detail about the components of hydroelectric power plant and their functions. Here is the cross-sectional view of a hydroelectric power plant. Now let us discuss each component one by one. Gantry crane. It is basically a lifting mechanism to facilitate the operation of the inlet water gate. Headwater. Water level at the dam is called as headwater. After it has passed through the turbine, the water flows downstream into the river, and the water in the downstream side of the river is called as tailwater. Trash rack. It is used to obstruct the debris to enter the turbine. It is made of bars and is placed at the inlet of penstock. Penstock connects the reservoir with the turbine propeller. When the gates of the dams are lifted, the force of the gravity makes the water flow down the penstock and reaches the blade of the turbine. Water turbines are used as prime movers, and their function is to convert the kinetic energy of the water into the mechanical energy, which is further utilized to drive the generator to produce electrical energy. Draft tube allows the turbine to set above the tail race so as to carry out inspection and maintenance. It produces diffuser action, such as the major portion of kinetic energy at runner outlet can be recovered, which would otherwise go to the waste. Tail race. Tail race is the water channel that takes the water out of the turbine. It is usually located at the outlet or exit of the turbine that converts the kinetic energy of the water at the outlet of turbine to the pressure head. Similarly, an outlet gate is provided at the outlet of the turbine. It can also be used to isolate the turbine from the water reservoir and from the tailwater. Spillway acts as a safety valve in the hydel system, as the pressure safety valves are used in thermal power plants. It discharges the overflow water to the downstream side in a condition mainly arising during the flood periods. These are generally constructed of concrete and provided with a water discharge opening shut off by metal control gates. The discharge of the water to the downstream side can be regulated by adjusting and opening of the gates. The generator produces the electricity which is injected into the grid and the system. The power produced in the generator is transmitted through the power lines. I hope that you must have received a good technical in-depth details of hydroelectric power system. Now let us discuss another very important equipment of hydroelectric power system, which is called as surge tank. Load demand of the system is always not constant. In cases, a load demand is possessed, and on the other side, a high load demand can be asked from the grid controllers. So the water flow rate into the turbine must also be regulated in order to meet the system demand. For this purpose, a surge tank is connected to penstock near to the turbine. A reduction in load on the generator causes the governor to close the turbine gates and thus creates an increased pressure in the penstock. This may result in water hammer phenomena and may need the pipe of extraordinary strength to withstand, otherwise the penstock may burst. To avoid this positive pressure and water hammer phenomena, some means are required to be provided for taking the rejected flow. This is accomplished by providing a small storage tank or a reservoir called as surge tank for receiving the rejected flow and absorbing the excess pressure in the penstock. This was basically a low load demand condition. In case increase in load on the plant causes the governor to open the turbine gates and allow the more water to flow through the penstock to supply the increased load, and there is a tendency to cause a vacuum or a negative pressure in the penstock. Under such condition, the additional water flows out of the surge tank. As a result, the water level in the surge tank falls. An accelerating head is created and the flow of water in the penstock is increased. This surge tank helps in stabilizing the velocity and pressure in the penstock. Although the Hydel systems belong to the category of conventional systems, but they are the only type which is renewable in nature. They have a very low operating cost. They produces no gaseous emissions and wastewater. They have a quick startup and shutdown time. They very quickly respond to the change in system load demands. That by just regulating the flow, we can meet the system demands of load. The life of hydroelectric power plant is high as compared to a thermal power plant. They also help in flood prevention and store excess water. Now coming toward the demerits, since these type of plants are located away from the load centers, so the cost in terms of transmission lines and transmission losses is high. Large dams usually take up large spaces on the earth, so they may involve the relocation of the human habitation from that area. Low water quality can affect the life of such systems. Building up of the silt behind the dam may limit the life of the reservoir. They have very high initial capital cost. In case of less rain and low water reservoir, the availability of the power over the entire year can be compromised and will definitely be less. That was all about today's video. I hope you have enjoyed the session. So keep connected, stay safe. Thank you.